Hey everybody, welcome back to another 15 minutes with me, Mr. Oldenburg. You're welcome. Today we're going to talk about critiquing reasoning. So we're going to look at some other people's work and judge it. We're going to be nice, harsh judges. We're going to say, I'm better than you, and I'm going to figure out what you did right or wrong, and I'm going to tell you what you did right or wrong, and basically lay the smack down. You know, all the things you're told not to do to people, we're going to do right here. It's going to be a lot of fun. Here we go. So today we did a whole thing about running in September, that these were the different days that these kids ran, and these are the distances that they ran during these days. So every day is an X. Each of these is one day. So then they said, all right, well, 4 kids in this class made some statements. Where our job is to now take a look at what they wrote, figure out if what they said is right or wrong and why. So, we have Olivia over here, and she says that the distance they ran the most often was 3 miles. You don't just jump and do something. And if you don't get what they mean by it, you stop and think about it first. So I'm thinking here, hey Billy!
Hello.
You're in the video now.
Yeah.
When I see that they're talking about the most often was 3 miles, I'm thinking, oh, Hannah and Danny too? Why are you guys here? It's library time.
Lessons.
Oh, again? So, I'm thinking that we have to run 3 miles, and the most often. That means the most amount of occurrences, the most amount of time something's going to happen. It's going to be the tallest of the bars with X's. So here we have 1, 2, 3, 4, 5. There is no value greater than 5. So Olivia's correct because 3 miles were run the most amount of times. Michelle says that the team ran different distances on different days and that they usually run for 2 miles or more. Now what I'll tell you is Michelle is partially correct. Her first statement that the team ran different distances on different days is not correct, because that would imply that each of these X's would be on a different distance, where I can see that there were 2 days that 1 mile was run. There were 4 days that 1.5 miles was run, and so on. So in that case, she's not right. However, she wrote, we usually run for 2 or more miles. So let's take a look at that. First of all, I can include 2 because it said 2 or more. So I'm going to look at all of these values. Now, if I count them up, I'm going to see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 days they ran 2 or more miles. Less than, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 days they ran less than 2 miles. So now I'm comparing numbers. I'm comparing days. I have 13 here, 8 here. Well, obviously I ran most of my days greater than 2 because 13 is greater than 8. So good job on that one. You get a 50. All right, we get Natalie. Poor Natalie. Natalie's not going to be right. Sorry, Nat. She says that the team ran 8 different times, each time for a different distance. Well, here's the thing with Natalie. We said that the X's were different times, and if we count all of these X's, we're going to get 21 times. What Natalie was doing was she was thinking of the distances. 1, 2, 3, 4, 5, 6, 7, 8. She would have been a little more correct if she said the team ran 8 different distances. Then that could have been right. But times, they ran 21 times, not 8. And then she said that each time was a different distance. Well, no, because look, we have repeats again. So sorry, Natalie, you're completely and totally incorrect. And then we get Pete. Poor Pete. Only boy in the group. It's not a good outlook. However, Pete tries to trick you. That's what I like about Pete. My best friend's name is Pete, just so you know. Each day, the team ran the same distance or a little bit farther than the day before. So initially you're thinking, oh, well, each day they ran the same distance. And if you stop it there, it can't be right because you would have a whole line of the same distance. But then he adds, or a little bit further than the day before. So what's Pete thinking? Pete's making a typical 5th grade mistake. Just like when we read, we start with the left. He's thinking the first day you ran half a mile, the next day you ran 1 mile, then another mile, then a mile and a half, a mile and a half. So it's always the same or more, because you don't go backwards. However, the problem with Pete's logic here, who says that that's day 1? No one. So if it's not said that that's day 1, then you can't assume that it's day 1. So Pete's wrong just because of that. Sorry, buddy. Down here, it says that Quinn said that to find the total distance, total, keyword for addition, add it all up. The total distance the team ran in September, you add each number that has an X above it. So he'd add a half, he'd add 1, he'd add 1.5, 1 3/4, etc., etc. Do you agree? And we said no. And the nice thing was everybody yelled no. And the reason why he isn't right is because of the F word. I know we've been saying the F word a lot in class. We still kiss our moms with those mouths, but we've been saying it a lot. And that word is frequency, because we're looking at the amount of times something happened. This happens more, one happens more than once. It's frequents it twice. So just like when we set up the other day and we were setting up the problems, first I'd have half times 1 plus 1 times it happened twice, the frequency. Then 1.5 times 4. Oh, look at that. So frequency, he's missing the frequency, and that is the whole bread and butter of this. Without the frequency, you're just looking at what the value of a unit rate, or 1, is, and you want more than that. All right, couple of things before we start this guy. The first thing is, you need to read this. You can't start a chart or a table or whatever you're looking at without reading what it's about first. This is like when you read a chapter book and the first paragraph is all in italics and everybody skips it because everybody's like, oh, it's not part of the text. Meanwhile, the italicized words give you a whole summary of what's going on. It's probably the most important thing you could have read in the entire chapter because it sets it all up. So always make sure you're reading so you know what you're talking about before you look at the data. So, Mrs. Kelly's class made a line plot showing how many hours each student spent watching television the previous evening. Amanda said, "No one watches TV for 3 hours." And Drake said, No. 3 of us watched TV. 3 of us watched no TV. Yeah, try acting a little bit more, Mr. O. Watch us say the words incorrectly. Who is correct, and explain. Now, here's the deal with this. If you read it like that and mess up like I did, you're going to say, I don't get it. I don't know what just happened. It sounds similar, but it's not the same, because it's not. You have to take the second to go back, and you have to reread. Back from lessons?
No, Danny's making me go back to library.
You're killing me. So anyway, you have to reread what they wrote. Amanda's saying no one watched TV for 3 hours. Okay, so let's stop there. She's saying 0 people watched 3 hours of TV. I'm going to go to my chart. I'm going to find 3 hours. What do I see? I see that 1 person watched TV for 3 hours. Sorry, Amanda, you're not right. But we're going to check what Drake had to say, because you never know. Maybe he's wrong too. He says, and forget this word no, because that's going to confuse you, 3 of us watched no TV. Well, what does no mean in the math world? 0. How many people watched no hours of TV? 3. So, good job there, Drake. Nailed it. Andre, which is the name of my daughter's new beta fish, says more than half of us watched the TV for less than 2 hours. So, more than half of us watch TV for less than 2 hours. I cannot use the number 2 in this because it doesn't say 2 or less. It says less than 2. Oh, look over here. This is less. Now, quite honestly, just from looking at it, I can tell he's right. However, I always got to show my work. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 people watched for less than 2 hours. While 3, 5, 7, 8, 10, 11 people watched for more than 2 hours. Now, if I were to add these, you get 24. 24 divided by 2 equals 12, so 12 is half. 13 is greater than half, so yes, more than half of the class watched less than 2 hours. Yes, here we go. Renee works at a sand and gravel company. Good for her. Good. Sounds sedimentary to me. Hope she's not getting weathered by all the hard work. I wonder if her days are just eroding away. Don't take my terrible jokes for granted, kids. All right, let's get back to math. So, Renee works at a sand and gravel company. She makes a line plot to show the weight and gravel in last week's orders. She concludes, all right, so this is a statement. She's concluding, she is stating that 1/3 of the orders were for more than 6 tons. I'm not even going to look at the chart yet. What is Renee's conclusion? I don't get it. We just read it. Like, seriously, it's right there. But I guess I'll do it anyway, because I'm a good person. So, Renee's conclusion is that 1/3 of the total order was more or greater than 6 tons. How did she support this? She made a line plot. I mean, quite honestly, they didn't even tell you how she supported it, aside from that she made a line plot. Describe at least one thing you would do to critique Renee's reasoning. All right, I could do that. I would hope so, otherwise they shouldn't be paying me. So, one thing is, I know I have to find the total. The total amount of orders. And I need that because how am I going to find 1/3 if I don't know what the total is, right? Then what would I do to solve it? Well, I would divide the total by 3, because that'll give me thirds, and that'll tell me what 1/3 equals. So here, if you count the amount of orders, you're going to see that there are 12. And then I divide that into thirds, 1/3, 3 is the reciprocal, and you get 4. What does 4 mean? 4 is 1/3 of the total orders. So basically, I have to have 4 orders that are greater than 6. So I go back to my chart. I find 6. I draw my line. I look over to the greater area, and I notice that there are 4 orders that are greater than 6. So, does Renee's conclusion make sense? Yes, because, put a comma there, Mr. O, because 1/3 of the total orders, and you have to restate everything. This is like doing a science fair project, if you haven't noticed, or rephrasing your question in the answer like in ELA. Because 1/3 of the total orders is 4, and there are 4 orders that are greater than 6 tons, she is correct. Bam. And guys, it's all written here. It's everywhere. As long as you show all your work and things like that, you're just repeating yourself step by step. That's it. All right. Aaron, or Aaron, made a line plot showing the weights of the heads of cabbage he picked from his garden. He said since 1.5 plus 2 plus 2 1/4 plus 2 3/4 equals 8.5, the total weight of cabbage is 8.5 pounds. Oh, Aaron, you need to learn the F word. It's called frequency, buddy. Let's go tell you why you're wrong. Describe at least one thing you would do to critique Aaron's reasoning. I would show him or tell him the F word. It's one thing I would do. So, describe at least one thing you would do to critique Aaron's reasoning. I would say, although his values were good, he forgot how many times they happened. Because when you have that 1.5, he should have had 1.5. But there are 2 of them. So he should have had that twice. And so on and so forth. Is Aaron's addition accurate? Show us how you know. Yes, his addition is accurate if he's doing this equation. Because you get a common denominator of 4, so that's 2/4, and it all adds up to 8 4/8. And then 4/8 divided by 4 is 1/2, so you get 8.5. So yes, his addition is accurate. Can you identify any flaws in Aaron's thinking? Yes, I just said the F word like 3 times. Frequency. He forgot his frequency. So I would write something like this. There is an error in Aaron's thinking. While he listed all of the weights, he did not list the amount of times each weight happened, also known as the frequency. Does Aaron's conclusion make sense? No, we just said that. Oh, it's like, gosh, you're asking the same question 5 times. No, it doesn't make sense because he didn't use the frequency. They're really beating that in our heads. But that's a good thing, kids, because you need to know frequency. That's it. It's a wrap. Hope you enjoyed it. Have a good one.